Hey everybody, this is Larry. I'm doing this problem as part of a contest, so you're going to watch me live as I go through my dots as I'm coding. There'll be an explanation near the end, and for more context, there'll be a link below on the actual screencast of the contest. How did you do? Let me know how you do. Hit the like button, hit the subscribe button, and here we go. Yeah, so Q4. So if you fast forward through this, you will see the live, me solving it live and my commentary and my thought process. But it turns out that some parts of it was wrong, namely that it seems like I got lucky with the solution and I ran an end to the fourth solution, which was fast enough in C++. But there's actually another solution, and I just want to point it out here so that people are not confused when they watch this video. But basically, the idea there is a n cube algorithm based off the point that given 2 points, say, given 2 points, um, given any 2 points, and this is horizontal just for easier visualization, but there's you can draw a third point, which is the center of the circle, in which, given that R is one of the constraints, which makes it different from another solution with other circles. Um, Given that R is part of the input, you could draw these 2 points and then calculate the third point that way. And from that, you could draw a circle that fills up the entire. Okay, I didn't really do this the right way, but maybe something like that. Anyway, okay. So this is a terrible circle, but I hope you get the idea. Basically, you're able to draw a circle that fits those 2 points with that other point in the center. And there are 2 points like this because there's this one, the one that I just drew, and also, by symmetry, the one that goes downwards, right? And of course, the radius is also R here. And then you can draw a circle another way. I'm not going to draw it, but yeah, in this way, there, for each circle that we drew, you can check to see whether each other point or how many other points are inside that circle to check. And that's pretty much how you would solve this problem. And for and you could see that for the bottom circle, you could do the same thing. So, and for each of that, you have to check each circle. You have to check of n number of points or n number of points. So overall, this is and there's 2 circles, so it's 2n. So how do you? So you may ask, how do you choose which points to pick as these 2 points? Well, you can just actually brute force checking all n square or n choose 2 pairs of points, and then test all of them. This will give you an n cube algorithm, which is way more than fast enough, and that's how you would solve this problem. Watch the rest of this video if you like, and I live solve it. I explain my solution, which is a little bit different and not fast enough at all. But I changed it to C++ and it's submitted and it was okay. I actually later, if you stay all the way to the end of the video, or by fast forwarding or whatever, there's actually I do a code review where I look at other people's solution, and that's when I was like, oh, I missed this thing. But so I guess but sometimes better lucky than good. Anyway, keep watching and thank you for watching. Q4, maximum number of dots inside a circular dartboard. So this one, it's kind of sad because I've solved this problem before. So when I saw this problem, I knew how to do it immediately. I was like, okay, it's n cube. Well, n cube times n, so it's n to the fourth for me. Yeah, and that's basically is brute force. So you're gonna so a lot of times you're not gonna see it on screen. But what I was googling, what I was doing was googling the entire time about the formula. And what formula, you may ask? Well, for this one, I knew that there are only 3 places the center point can be, or I'm gonna call them candidates. There are only 3 type of candidate points. One is, well, each of the input points themselves. 2 is given 2 points. You use the midpoint and then draw a circle radius r and then see if they're inside. All of them are inside. And then the third way is given 3 points. Given 3 points, you could uniquely determine a circle, and for that circle, um, uh, check the center point, and then check whether that, and then use that center point as a center point to count all the ends. There's some optimization you could have done, I could have done, but I didn't do it here. And I think I spent a lot of time just googling the formula for the last part because as much as I have been doing competitive programming, I don't. Well, one is geometry is hard for me. I haven't done it in 20 years. These are excuses, but my point is still that, um, excuse me. My point is that I'm rusty and I was not ready to solve this problem. But I also knew that it was a formula that you can Google, though. Well, that's what I thought at the time when I was thinking about this. But I did run into a lot of, I don't know. It was harder than I thought to Google, not how to solve it, but a way to implement it in a clean way or able to implement it in a clean way. And that's what I struggled with. But now we're just doing the case where you have given 2 points, use the midpoint of those 2 points and draw a circle from that. I think I could have done some optimization here, but I didn't. So that was a little. Now that I think about it, I could have, but that's okay. But yeah, now I'm just using the midpoint formula for Q for 2 points. And also note that I intentionally, I don't know why, I do use unnecessary number of loops in the sense that, yeah, now I'm looking like just to make sure that like maybe I could use that constraint to figure out a way to um, like can I do something on the latches or something like that? But I was like, now just do it for I was like telling myself this, Larry, you know how to do it. Stop. I mean, maybe there's an easy way out, but you're not going to be confident about it anyway, and then you're going to be annoyed. Just do it the right way. That's basically what I was telling myself roughly at this point. Here I'm just setting up the best thing. And right now we're about 3.5 minutes in or so, give or take. Um, so kind of slow even on this part, but I mean, I didn't spend the entire time doing this part. I was just, I think I did some Googling, and I think I had, um, I had a formula ready. I don't know if I was ready to implement it, but I had a formula ready, and yeah, I should have just did it with determinants, something. But yeah, and this is pretty straightforward. I don't know why I did it, and like I didn't. Should count from J from I to K. Oh, sorry, from I to J. Sorry, J from I to N, but I didn't. So it was kind of sad. And also I wasted some time here because I did range of points instead of length of points on the top. Uh, but that's okay. So now I knew that this wasn't correct because I didn't do the other part. So now I'm like, okay, it's Googling time. Um, but I'm going to fast forward a little bit. So feel free to, well, I mean, not fast forward, but I'm going to skip ahead. Feel free to watch this on 2x or something like that and then kind of see my logic. But a lot of this is just me Googling. So yeah, I will join you back later. Remember to use the links below to kind of move along. But see you in a sec. Wow. Well, welcome back, or welcome me back. Thank you for welcoming me back. No, but yeah, I did the formula. As you can see, I've been debugging. Unfortunately, I had a typo on the formula, and you kind of see me here. This is at the end of all the debugging, but I just flipped one sign, and that one sign was enough for me to get it wrong. For 10 minutes, I was debugging for 10 whole minutes, trying to figure out what's wrong. And I still finished in the top 100, I think. That 10 minutes would have been really helpful. I would have been
10,000.
definitely like top 50. And if I didn't even have the 5 minute, like if I had submitted now, but this is 31 minutes in. So even if I had gotten this right now, I would have been top 25, even with the 10 minutes penalty or 10 minutes debugging. So that was kind of silly. But as you can see, I have time limit exceeded. And I just don't know how. I was like, what? No, how do I do this? Like maybe I could cache this. Maybe I was being a little bit lazy on the on the on the commutation. Like I was like, oh, maybe I could just be a little bit better around the commutation. Um, but yeah, but that 10 minutes was a little bit sad. That 5 extra minutes was even more sad, uh, just because I had one sign flipped, and it took me a while. And some of that is that debugging really depends on your confidence. And if you're really confident on your formula, then you know that you implemented the formula well. Versus me, I was not confident about my formula. And what I mean by that is that because I was not confident in my formula, I spent a lot of time during that 10 minutes just Googling alternative formulas just to kind of double check. But it turns out that I just had a typo, flipping one. I mean, like this BAC thing, it's really long and it's very easy to make a mistake, clearly. And I did make a mistake, but because I wasn't confident in in general, it took me a long time to catch that one. So definitely an opportunity lost here. I probably could have done it in much less time. But here, I was like, okay, I'm still running into time limit exceeded. I don't think I could do any better. We'll see later whether there's a faster algorithm. I don't know of a faster algorithm. So like if this didn't work, I didn't have any other way. So you see me kind of struggling for 2, 3 minutes, just trying to figure out what to do. I ended up spending 8 minutes here, but what I ended up doing was I was like, okay, I did the math again. It's going to take about, the worst case is going to take about 16 million operations or so, 17 million, something like that. So like, okay, it's C++ time. So yeah, that's pretty much it. I literally re-implement everything in C++. There's a typo that didn't matter, it turned out, but yeah, after I implemented in C++, it seems like I spent about 5 minutes before submitting, and just double checking that I guess everything was right and doing minor optimization. And also I don't have a great keyboard, so I was just not typing as fast as I feel like I could have. But yeah, but that's all I have for this problem. Let me know what you think. Hang out with Larry up there. If it's a little bit boring for you, skip ahead a little bit, 10 seconds at a time. There'll be link below to kind of for you to jump right to the explanation portion and stuff like that. Anyway, I will see you later. Bye bye. Well, hang out about the Larry. See you. Q4, maximum number of dots inside a circle dartboard. So I knew how to do this immediately. I've done this before, which makes it a little bit sad that I took so long. The short story is for n, so your midpoint will either be on one of the points, one of the endpoints, or one of the points between 2 points, or which is the midpoint between 2 points, or the center of 3 points that forms a circle. So you could do some math to prove that 3 points uniquely determine a circle, and from that you just brute force. Given that n is equal to 100, this is n squared, which is okay, obviously. Well, this is n squared times the cost, the n. So for the 3 cases, for 1 point being the center point, there's all of n cases of them, and it takes all of n times to count. So that's n squared. For the midpoint between 2 points, there's n squared of them, and it takes all of n to count, so it's n cubed. That's what I have here. And then for every 3 points forming a circle, there are obviously n cubed of them, and then each of them costs n times, so it's n to the 4th. This is where the constant matter, because you could choose n choose 3, which for 100, n choose 3 is a lot less. It's like 100 million over 6 instead. So, wait, is that right? Yeah, 100 choose 3 is only 161,000, where 100 cube is much bigger. It's about a million. So 167,000 times 100 is only 16 million. But in Python, it's still too slow. So I got a timeout for that. And you saw me rewrite it in C++ just to get it inside the time. Is there a more smarter way? I'm not sure. But well, I mean, you could do some pruning probably, but in a general sense, in theory, you cannot do in a better time because you're given R. Yeah, and you just have to check for each point. So given a candidate, we have to check that each point is closer than R from it. That's pretty much it. Yeah, that's all I have for this problem. It's brute force. That's why it's a little crappy, because I knew how to solve it. I knew it was brute force. I've solved this problem before. But one is that in Python got timed out. That's sad. 2 is it took me way too long because I wasn't super confident about this formula, and I had typo, if you saw, for a long time. And I wasn't, because I had to Google the formula, I didn't really understand the constraints. So like for this case, I didn't know what does it mean when a is equal to 0. That means the determinant is equal to 0, but I'm not sure. I didn't know what that means or like geometrically, and that's where practice and stuff like this gets you. I think it's probably just that 2 points are collinear or something like that, but I'm not quite sure. Not collinear, co-circular. No, that I don't know. But some weird things like that. So I had to get rid of it, or it gave me a divide by 0 error for. Oh, actually, I think I messed up. Somehow it got still accepted. I think when I was writing my Python code, I had this before this. So otherwise, because if this is 0, then it would give me a divided by 0 error. But maybe there's some weird thing where this just gives me not a number or something, and that's what. But so it seems like I made a bug, and almost cost me 5 minutes again, but I did it correctly in Python, I believe. It's just that I didn't run in time. But yeah, I took way too long because I reverted one of the signs, and then as soon as I changed it back, I was okay. But I was still not confident. I probably should have tested the n is equal to 100 case in Python before submitting, but I didn't know of a faster way. So maybe there is a faster way. We'll kind of see the solutions later. But for me, I didn't. I feel like I remember solving this problem, and I didn't remember a faster way. Clearly. Okay, Q4 is the most interesting part. Um, let's review Q4. I mean, he's really good, and he did it in 32 minutes, so I don't feel that bad about it. Uh, yeah, so it turns out, I mean, you might have watched the earlier part of the video, and I said, like, there's no easy, I don't think there's an easy way to do it better than n cube. So it turns out I was wrong, um, because the tricky thing to note is that you're given R, and the OR allows you to, instead of building a circle from 3 points, you could use OR to find the third point, and then there are two points. So given two points, so you still brute force the 2 points, so it's n squared number of candidates. Given those 2 points, there's only 2 other points that form a circle all units away. So there's one on top and one on bottom, if you want to put it that way. And then from those, for each of those 3 circles, you just try to brute force it to calculate for all of n. And that's all of, yeah, so that's n cubed. So you can do an n cubed. So if you do it in Python, then it should have been way more than enough. I did it in Python with n to the 4th, and instead I did it with n cubed, and that seems to be okay. Or n to the 4th, I did it in C++, and it made it okay, but I probably actually don't deserve this, to be honest, because I did not think about this solution during the contest as well. That one, also same thing here. Yeah, also same thing, getting the centers, and yeah, getting the centers of the circles, and yeah, doing it that way. That's pretty cool. And you could probably have, you know, maybe I needed to break out my notepad for this one. But yeah. That's pretty much what I had. Cool. Yeah, I mean, I guess I just needed to do more math. What a tricky problem.